Good evening and welcome to the final day of Quality Week 2022, a 5-day event with 2 incredible sessions taking place each day. This is an event organized by the Colombo Quality Camp and sponsored by our strategic partner 99X. So I'm Dean Suharni and I'll be your moderator for this evening. So we have 2 more amazing sessions planned for today and hope you all stick around for both. So now before we kickstart our sessions for the day, let me kindly remind you to type in any questions you have for our speakers in the chat, and our speakers will answer them at the end of each session. So let me introduce our first speaker for the day. Prasadie is the Associate QA Architect at 99X and has 12 plus years of industry experience in software quality assurance. She has experience in time-critical business domains, such as stock markets and travel and holiday management fields. She is deeply committed to process innovation, quality engineering, and providing value to customers. She also provides QA consulting to several other 99X projects, assisting them in delivering excellence. She is strongly motivated by the motto, knowledge is power. So learning has become a never-ending journey for her. Here's Prasadie Senadheera speaking on the topic, testing in DevOps. Over to you, Prasadie.
Thanks, Devi. Thank you for that nice introduction. Right. So let me share my screen first. Right. So hope you guys can see my screen. Yeah.
Yes, Prasadie can.
Okay. Right. So today we are going to talk about DevOps. So this is quite a buzzword over the last decade, so nothing new. I think most of you have heard of this. Right, so before going into the session, is there anyone from universities, any undergraduates here? Raise of hands. No, okay, right. All right, guys. So today's lineup. So I didn't want to have this same boring content slide. Rather, I was thinking of focusing the key areas that we are going to talk about today. So there are 3 different aspects. Starting off with, of course, the understanding of DevOps, and moving on to DevOps life cycle and continuous testing. And finally, we'll be talking a bit about the cultural change and the QA transition. Right. So anyone who have not seen this diagram? Anyone? Okay. So I think this is nothing new. We have seen this number of times. So this is the DevOps life cycle. Starting from planning, plan, code, build, test, release, deploy, operate, monitor, and the life cycle goes on like this. So this is a continuous life cycle, and there are 2 main parts that contributes to this life cycle. One is development and the other one is operations. So when you take the development aspect, it's not only the people who develop the code, it also incorporates BA, Dev, and QA roles. So altogether, we call as a development team. And from the other hand, of course, the operations engineers who take care of the delivery in the live environments and also health monitoring of the live system. Now, when you hear DevOps, for many people, they feel like it's technical. I mean, it's technical, but of course, when it comes to the tool chain, it's technical, but DevOps is essentially a culture, right? So the most important part here is to understand the culture or the cultural shift. So in one of these interviews, the pioneer of this culture, in one of these interviews, he was asked, what is the most important factor of DevOps? So this his straight answer was thinking. So it's not the tool chain, right? So DevOps is about, it's not about a set of tools, or I mean, it's the tool is just an instrument that drives this culture. So a brief history about DevOps. So this was originally started in 2008 by a person called Patrick Debois. So it's not Debois, it's Debois. It's a French surname. And so he's the like the godfather of DevOps. And he started the discussion with a set of people. That was the very first conference about DevOps. So the goal of this conference was to discuss how the delivery of a product and the infrastructure aspects can be combined with agile software development practices. So that's the very first discussion, as that's the starting of DevOps movement. No, I was trying to find a one definition for DevOps. So if you go through the internet, there are several definitions for DevOps. This is just one such one, because I took this, just wanted to put something in writing just to make it a bit more formal. So DevOps is a set of automated software practices, mark the word practices, that combine software development, testing, and IT operations to shorten the software development life cycle. Now, when you look at this definition, it mostly sounds like agile. So this is exactly what's happening in agile also. So you might wonder whether there is a difference between DevOps and agile, or it is similar, or is there a line in between those two? So that's obvious question. So this we will talk about in one of the upcoming slides. Right. Now, if you take this DevOps life cycle, so there are different stages starting from plan, code, build, state, test, release, and the life cycle goes on. But if you take all of these stages, we can identify 5 different primary stages. So starting from planning, plan, code, build, stage, and deploy. So this is the primary stages of the DevOps pipeline. So today our main focus is on these 5 different primary stages of the life cycle. Right, moving on. Now, when you take this, as I said, DevOps cycle is a continuous cycle. So all these activities that happens in the DevOps pipeline is continuous. So what are the activities we have there? We have continuous integration, continuous delivery, continuous testing, continuous deployment, continuous monitoring, continuous feedback, continuous improvement, and innovation. So those are the key continuous activities that take place in the life cycle. Now, this is a lot, right? So today, of course, with the time restrictions, we can't talk about everything here, but for the time being, I will focus on few aspects. The first one is, of course, continuous integration. What happens there is the code is continuously committed to the source code management system, and it is continuously verified on top of a build. So it makes the developers' life easy so that they can collaborate and keep the code centralized. The next one is continuous delivery. So that is mainly about packaging. So in order to release this to production, it has to be packaged and it has to be kept ready for deployment. So that's about continuous delivery. The next one up is continuous deployment. So that means you are continuously deploying your changes or the updated software to the target environment. So obviously it can be test environment, it can be staging, or it can be even a pre-production one. The final one is continuous testing, our key focus for the day. So this essentially means that the testing activities in the pipeline has to be started very early and it has to be continuous throughout the pipeline, right? Okay. Now, since DevOps is sort of the buzzword during past several years or past decade, do we have to implement it? I would say no, because Now, if let's say if you are in a startup project, if it works fine for the customer, if the customer is happy with your delivery speed, if the customer is happy with the quality that you're providing, then you don't really have to worry implementing DevOps just because it's the modern practice, right? But having said that, if you are experiencing a sort of a quality issue or a speed issue, I mean the productivity issue, or else if you can sense some sort of a similar issue in your future, then obviously you have to think about DevOps, because speed and the quality are the main two objectives of DevOps. So what are the goals? Or I would say the benefits of DevOps implementation is obviously to increase the speed of your development and to make your builds more reliable through extensive automated testing, and to shorten the turnaround of your feedback loop, and to have greater scalability, because scalability in the sense, we of course in DevOps, it talks about cloud computing or the cloud infrastructure. So without cloud technology, we can't think about DevOps. So anytime you can expand your infrastructure, you can maximize, you can increase the size of your database, you can increase the instances, so that capacity is there with DevOps. And increase security, because in DevOps, it encourages to incorporate these security assessments into the pipeline. So with that, we can increase the security of the developers. And finally, close collaboration with your development team. Right. Now, in one of the previous slides, I told you that is there a difference, or is there a relationship between Agile and DevOps? Yes, these are connected. Let's see how. Now, DevOps incorporates Agile principles and practices. So all the underlying practices or concepts are mainly from Agile. One example is close collaboration. So in Agile Manifesto, it says close collaboration. I mean, people is prioritized over processes and tools. So that's one of the core concepts, collaboration. And in both these cultures, or in both these processes, development is happening as usual. So it's pretty much the same. But in traditional Agile way of working, it does not really talk about operations aspect, how the ops engineers come into the picture. But on the other hand, in DevOps, this is a critical or an integral part of DevOps shift. Now, DevOps replaces the old approach of development teams writing the application, and it's just thrown off the wall to the operations team, who doesn't really know what happened in the development phase. So that culture is not encouraged in DevOps, because the DevOps says that all these different engineers from different disciplines has to work together, has to collaborate from the very beginning of the life cycle. Sorry. Okay. Right. So this is the key focus for the day. So I'll be talking about these different areas. One thing is risk-based testing. The second one up is exploratory testing and test automation, and then continuous testing in DevOps pipeline. First one, risk-based testing. I think most of you might have heard of this, because even when we are just communicating with the other parties, we always use this word risk. So we have to check the risk, we have to consider the risk. So that discussion is anywhere there. But this is a separate testing type you can incorporate in your pipeline. Now, today in this session, I'm not really going to talk about how we apply the risk-based testing, because it is a quite lengthy session. We can separate one whole session for this topic. But today, my main focus is on what is risk-based testing and why we need it, right? So in the typical Agile practice, one of the common complaints that an agile tester has is the lack of time. Because normally we get all the changes toward the end of the sprint, and we usually run out of time. So in that, in such scenario, the first question we have is, what feature do we need to test first? So that's obvious question. So the answer lies with this sort of a testing type, because with risk-based testing, you can prioritize what features you need to test first. So now, by implementing risk-based testing, what are the benefits? We can discuss in 3 different areas. One is customer focus, the quality, and the structure of the testing. So risk-based testing essentially gives you greater customer focus. Why? Because we usually start from the most critical or business critical functions. So our first focus goes to those features, and we essentially find the high risky bugs or critical or major bugs there. So with that, we obviously improve the quality because that's our main priority. And how does it make the testing more structured? Now, in the risk-based testing, it is easier to decide what to test or what features to test, where to start, and when to stop, right? So in other words, it's easy to define the test scope, right? So with that, when you have thousands of tests, it's very easy that you prioritize a set of tests or some areas of testing or scope down your test so that you can essentially meet the time limitation. Right. So the next one is exploratory testing. So I think this is not anything new. This is a pretty common testing type that we hear every day these days. So exploratory testing is, I would say, while testing, it gives the perfect learning experience for a tester. Because this is the combination of testing and learning. And now, one of the myths that we have in this testing type is that we usually think that this should be carried out towards the latter part of the pipeline, which is really not. Okay? So this can be applied in anywhere throughout the pipeline, and maybe by anyone. Maybe it can be developer, it can be a QA, it can be a ops engineer. So that flexibility is there. And this exploratory testing type essentially started as ad hoc testing. The usual the name was ad hoc testing, but later it was changed to exploratory testing. But one of the things that we can do to make it a bit formal or make it a bit structured is that to use a charter or a guide or a mind map that doesn't really take much time, and there are enough tools that facilitate this option like Qmetry, Practices, and there are enough tools that supports this testing type. So you can use one of those. And now the advantage of having this guide or mind map or a charter sort of thing is that now this is completely driven according to the way you work, right? Now you check one scenario, you find a bug, then you further drill down in the scenario. It's like you define your path while you're testing. While doing that, you might completely forget a whole area of your application, which might be a bit risky. So to make sure that it does not happen, if you have a charter, you know where you covered and where you have not covered. So even if you have to stop this testing within the given time period, in the next testing round, you know, okay, I haven't tested this part, so I can essentially start from this point. So that big picture, that overall picture can be derived through adding a bit of formal techniques into this testing process. Next up, why we need to have this testing types is obviously this provides the quick feedback while learning about the product. And without proper testing, test work products or test cases or test plans, we can easily run this early in the life cycle, in early iterations of the product. And of course, we can identify the edge cases, especially in a mission critical applications or high risky applications. And this can be used as a further step or as an aid to the unit testing process to get more confidence on the testing area, and of course to identify new scenarios. Now, how can this be linked to the automation? Because essentially we are talking about automation in DevOps culture. So whatever the scenarios that you identify in this exploratory testing phase, the things that you feel which are more critical or which can be common user scenarios, those things you can automate and integrate into your pipeline. So that is one of the key aspects of how this exploratory testing, the output of it and automation can be linked. Right. So the next one is, of course, test automation. Now, this is nothing new. I mean, throughout this session, we are talking about the test automation and automation in general perspective, because we can't really talk about DevOps without automation. So automation is one of the pillars of DevOps. So automation is one of the success factors of DevOps, and DevOps encourages test pipeline to be automated as much as possible. So that's the ultimate goal. But having said that, the team needs to identify the right balance. I mean, even it says that you need to automate as much as possible or every quality gate, there can be practical reasons that you can't do it. So in that sense, it's the responsibility of the team to identify the right balance. How much we are going to automate or how much we are going to leave it in manual test, right? So that completely depends on the project requirement. Okay. Next, we are moving on to continuous testing in DevOps pipeline. So this is a continuous testing is often called shift left testing. And so the rule of thumb here is that testing has to happen as early as possible and throughout the pipeline. And the outcome of a particular testing phase determines whether the software is ready to move to the next phase, right? So if something fails, that means the pipeline has to stop from that point onwards until that is corrected. Now by introducing continuous testing to the pipeline, we are trying to reduce the quality debt. And on the other hand, we are trying to identify the production bugs or which could release to production as early as possible. And through the continuous testing, so it determines whether the app is ready or the latest build is ready to go to the production. So in all, the goal of having continuous testing in the pipeline is to, there are several things that we can list down. Finding defects earlier in the life cycle, thereby increasing the quality, and shorten the test cycle, shorten the feedback cycle, and reduce the production defects. All right. So when I was going through some of the stuff about DevOps, so I came across one interesting thing. Now in Catalan Studio, in Catalan tool, they have this blogs. They have some information informative articles there. They have something called continuous testing maturity assessment. Right? So it's a very simple test. It's free. It had around 10 questions. And I found it very interesting because even I took that test. It gives some insights to your existing DevOps pipeline. So if I actually got some of the questions here because I wanted to show you guys. So one question they have there is, how do you usually trigger your automated tests when a new build is ready? So this essentially asks how you have planned your testing. How do you incorporate testing into the pipeline? So 3 answers. We trigger automated testing by scheduling. That means like daily builds. And we trigger automated tests manually, because some teams, they have it in local machine and just execute it from the tool itself. And the third one is we trigger automated tests automatically when a new bit is created, which is the ideal way of doing it. So likewise, there are a few questions which now finally, when you take the test, they categorize you into 3 different stages: initial, moderate, and advanced. So, and they also gives a detailed report based on that. So for the answer you provide, they give some suggestions whether it needs to improve or not. If your status needs to be improved, what things that you can introduce to your um, pipeline. So they come up with some suggestions. So I found that report very interesting. That adds a lot of value. So I would like to tell you guys, if you have time, just check for that assessment and take it. It would add a bit of value, of course, to your thought process. Right. Testing in DevOps pipeline. So these are some essential, some key points that I wanted to highlight. Testing spans across the entire software development lifecycle, and testers are no longer just focusing on functional testing or feature verification. It's like isolating one particular testing phase. The DevOps pipeline consists of various types of testing done throughout the stages. And the most important part here is, if you're planning to create your test pipeline, the main way, or the easiest way to approach this is to break down your pipeline into different stages. You can do it in your own way. It doesn't have to be according to the defined pipeline stages. Just try to come up with separate the stages and see what sort of testing, what sort of quality gates that you can incorporate into each of these testing cycles, testing stages. So that's how you kickstart of introducing a test pipeline. And so even though in the cycle it shows a separate testing stage, testing has to be integrated, or testing has to be carried out throughout the life cycle, and it has to be integrated to the pipeline as much as possible. Okay, moving on. So now we'll see when you take this the primary pipeline, let's see what sort of testing or what testing types we can apply in each of these different stages, right? So starting from planning, planning obviously is about gathering requirements, maybe documenting these requirements and validating, I mean, not validating, of course, but checking the accuracy or the testability of the requirement. So in this space, we can carry out static test techniques like requirement reviews, obviously. So it is also called pre-CI/CD testing. So what we really do there is we come up with accurate requirements by gathering all the different scenarios, different information from different stakeholders, and we are trying to come up with clear acceptance criteria, which is essential for the subsequent testing types. And also, while doing that, we will definitely come up with requirement defects. And requirement defects happens because of the ambiguous or incomplete or incorrect requirements. So during planning stage, what we can do is we can obviously carry out static testing type, that is obviously requirement reviews. So this phase is a place where we can add a lot of value as QA engineers. The next one is code and build stage. So here we can see 3 different areas. One thing is static code analysis. So there are enough tools out there like SonarQube, and also resharp, and there are so many tools that provide this facility, which is of course automated. And unit testing, again, it's a core part of development process. And then for unit testing, there are again number of tools like JUnit, TestNG, Jasmine. The list is, the list goes on. There are so many tools. And the third one is integration and API testing. So here, one of the success factors for this integration for API testing here is to mock the data, not by depending on external parties, let's say external APIs, because it might fail your test. So what we can do is to make it more encapsulated into the code. That means you have all the necessary items in the code itself and execute your test. So this is completely up to the developers to develop and execute. The next stage is the stage level. There we can identify 3 different testing types: functional testing, performance, and security. So you might think now usually in our own way of working with the typical agile way of working, usually performance testing and security testing is something that we afterthought. I mean, we think about it separately. We don't really want to have it in the same pipeline or in the same work flow, because it's time consuming and it's resource intensive. So we really don't want to have it as a part of your daily release process. But DevOps encourages you to have these 2 testing types integrated into the pipeline. So you can decide whether you have it in the staging state, or you can maybe have some critical performance test. Let's say validating your response time if it's an API. That can be incorporated maybe to the plan and code stage, or maybe you can have it in this stage. And there are tools also that provide this facility. Now, if you take the security testing, again, this concept called DevSecOps is there, which says that security has to be a part of the pipeline, not something separate. So there are tools like SonarQube, and there are other tools that like Fortify. So all these tools provides preliminary security assessment that can be essentially carried out during unit testing stages. So those things can be incorporated into the pipeline, and that's, it's the team's decision how you want to have the strategy. Are you going to completely have everything in this stage, or are you going to take some key tests and incorporate these into the plan and code stage, maybe parallel to the unit testing or after unit testing, or are you guys want to take it everything after deployment? So that's completely up to the team to design. So in DevOps, now the thing is there's no ideal way. They give some suggestions. So you have to decide what works for your best, for your project best. So just because it works for another company, or maybe it works for another project, it doesn't really say that it will work for you also. So same goes with the tool chain also. So it's our responsibility to find the best fix for us. All right. The last stage is testing during deployment. So this is about after deploying to the target environment. Let's say it can be test environment, it can be staging environment, or it can be a UAT environment. So there we can consider 2 different types of testing that can be added to the pipeline. One thing is functional testing, and the other one is combinatorial testing. So functional testing is means that this can be a part of your automated regression test also. Let's say if you have your smoke test automated, this can be integrated to the pipeline at this level. So it's like you are executing the business critical features again in the pipeline. Then the combinatorial testing can be automated, and in some cases might not be automated, because it focuses on areas like checking in different browsers, checking in different operating systems. So that's again completely up to the team to decide how you want to have your PV strategy. with that, I would like to show you guys some different implementations of test pipeline. So this is one of the diagrams I took from internet. It's not that clear, but I think you can see the essential parts. So here, now different types of testing are incorporated into the pipeline in different I mean, they have set of environments. For the unit and security testing, they are doing it on the CI server. Then the essential integration test, they have a separate environment executed, that is the integrated environment. Then system test, maybe this can be your automated regression test. So that executed in another environment. Then they also have performance and other like acceptance tests, maybe if you are using like a tool like Cucumber, which supports VDD approach, then those can be used for feature verification testing and bit of manual testing also with exploratory testing. And finally, user acceptances may be from PO or somebody from the business side. So now this diagram is just another way of implementing continuous testing. And the key thing is that they have number of different environments. Now, ideally, in our cases, this might not be practical because creating environment in cloud infrastructure means cost. So in that case, we have to think about the cost aspect also, but this is just one of the examples. The next one is, again, this gives the pipelines with more or less our case, I would say. From the code commit, it triggers the build, and from that build on the dev environment, unit and integration test is executed. And then from there, another build happens to, let's say, test environment or maybe staging environment. And automated regression tests can happen there, which is incorporated to the CI/CD pipeline. And maybe a bit of a performance test there. And when that is okay, if it's okay, then we can go ahead and deploy in the pre-production environment. Then there you can have your smoke test automated to the pipeline. So this is just another interpretation of a pipeline. Right? So the third one, again, sorry, this words are not a bit clear, but I think I just explained the flow. So this is again a different way of interpreting the different stages of the pipeline. Planning from starting from plan, they have development and version controlling, then testing, and the pipeline goes like that. So when a commit happens or the code checking happens, it enables or it triggers a build, and the builds get failed. So it gives the feedback to the development team. Then the developers do the change. Again, a build is triggered. So then on top of that, maybe you can execute some, let's say, your regression test, or maybe whatever the test that you have planned for your pipeline. And then from that point onwards, few tests might fail. Again, you can go back and get the feedback. So likewise, until it gives the green light, the cycle goes on like this. And finally, you can add a bit of manual testing for the pipeline, because now, even though in the DevOps pipeline, it says like everything has to be automated or as much as possible, there are limitations from the technical perspective also, and also from the business side, because we can't just go ahead and deploy everything to the production, because we have to consider the peak hours or peak hours also. So essentially, we have to stop at one point, maybe from staging environment or pre-production environment. But till then, we can have everything automated as much as we can, and so that speed up our pipeline. So the whole idea by implementing DevOps is that the testing should not be a bottleneck in the delivery pipeline. So if it becomes a bottleneck, then our objectives, the main one is the speed that cannot be achieved. That's exactly why, if you're taking some time for testing, that is exactly why people see that testing is a bottleneck in the pipeline. So that myth we have to break. We can, of course, break through successful implementation of DevOps. Now, when you talk about the tool chain, which is an core part of DevOps implementation, so this diagram is very interesting. This has so many tools listed here into different areas like source code management, CI, build, and the list goes on. And also, we cannot forget about the other areas like in the tool chain of DevOps. We have to think about the project management side, communication for close collaboration, and knowledge sharing, and production health monitoring. So there are so many tools that you can consider and do POCs and then decide on what to take. Right. So finally, QA transition. So this is a complete cultural change from this typical divisional structure to a close collaborative team culture. And there, DevOps changes the definition of a traditional tester, and the DevOps require the tester to take the responsibility of the quality from the very beginning to the end of the pipeline. And to have that, we need to continuously improve ourselves by embracing this change positively and breaking the silo of this typical mentality of department structure or the typical traditional way of thinking, and share your knowledge as much as possible with your ops engineers, with your developers, and collaborate with peers, level up your skills through essential trainings like automation and other areas. And of course, continue to build your domain knowledge, because for test planning, domain knowledge is an essential part. And also continuously try to innovate your process. So this next slide summarizes the skill set, the test automation at the top. So that is a core part of our skill set. We can't be experts of manual testing only anymore. We have to have this skill, and we have to come out of our status quo, challenge the status quo, and gain some new skills while continuously trying to be experts of our domain and also process innovation. So these are two books that literally made me fall in love with DevOps practices, learning DevOps culture. So the first one, DevOps Handbook, is it's a very simple but comprehensive book. It focuses on all the aspects, starting from agile to DevOps implementation, KPIs, value chain, and everything. The next one is like a more or less a fictitious book, which has a case study sort of a thing, where a person is put in a very troublesome project and he has to resolve all these problems in the project. So those are very interesting two books. If you want to read more or learn more on DevOps, I would say start from these two books, which obviously will be very interesting. Right, I think we have taken extra time, and that brings to the end of my session. And before wrapping up, I would like to take some questions also. We have a few more minutes. Maybe.
Thank you, Prasadie, for that amazing session. So, due to the limited time period, we can take only like one question. Maybe the rest of the questions, she can answer them through the chat, or you can reach out to Prasadie on LinkedIn and maybe drop any questions. I think she'll be happy to answer. So you can maybe proceed with one question, Prasadie.
Yes, maybe I'll pick one. Could you please explain more on how risk-based testing incorporates with DevOps? So this can be, at the beginning, this can be a manual testing type. But since the way that we carry out risk-based testing, it requires very limited time because we are prioritizing out of so many tests. But so that's how we originally started. But then on the go, whatever the inputs that or the outputs that we take or the lessons learned from that testing type, we can increase the scope of our automated test suites, whatever the scenarios that we newly identified through this testing technique, that can be identified, that can be incorporated to the automation test suite. That's how you can incorporate these testing type to DevOps. Maybe can I take one more question, Devi? Do we have time? Yeah. Okay. Yeah. So what's your take on testing in production environment? So that's a very valid question nowadays. Now we know that with the GDPR, General Data Protection Regulation, there is a limitation to this. Now earlier back in the days, we want to verify once a release is done, we want to verify that in production. But now it's like limited with this regulation sort of thing. It is not really the case. In that case, that validation part in production environment cannot be done in the projects that have the this GDPR implementation or the GDPR agreement. But that's why we say we want to have the previous environment production like, even though we have to apply this removing PIIs and sanitizing all the data, but still it can be a production like environment. So that is the place where we can do all the final verifications. So, but for those projects which does not fall into the category of GDPR, obviously we can do the testing and production environment as we did in good old days. All right. Any time left? There's so many questions.
Yeah, maybe you can answer them through the chat, Prasadie. I think that would be possible.
I'll do it.
Yeah. Thank you so much, Prasadie, once again for answering all the questions and for that insightful session.
Right.
So, yeah.
Oh, okay. So one final word from my end. Thank you guys for making it to the final day, and thank you for being a lovely audience. And thank you, organizing team, for giving me the chance to speak in the Quality Week. Hope to see you guys in maybe one other session, hopefully. Till then, stay safe, take care, and have a great weekend.
Hope to see you soon as well. Thank you. So next up, we have another amazing individual speaking on the topic, testing in modern times, a story about quality and value, is Huib Schoots, a coach, consultant, and a trainer at Quality Accelerator. He's an expert in the field of context-driven and exploratory testing from the Netherlands with over 25 years of experience in IT and software testing. He's also experienced in Agile, enterprise agility, scaled Agile and DevOps practices, Agile implementation, and line and project management. Over to you, Huib.
Thank you. Okay, let me share my slides with you. There we are. Can you see my slides?
Yes, we do.
Awesome. Okay, then before we start, please go to this poll. Use the QR code, or let me copy the URL in the chat. That might be very handy. Why haven't I thought of this before? There you are. Where is the chat? There is the chat. So if you can fill in these 11 questions, so I can just have a little bit of insight on how you think on topics I'm going to talk about. And while you're filling that in, let me tell you a little bit about myself. Come from the Netherlands. I live in Den Bosch. I have, as I said, over 25 years of experience. I work for a company called Quality Accelerators and for a company called the Agile Testers. Both are heavily related to quality. The Agile Testers obviously is a testing company, and Quality Accelerators is a company where we help companies to accelerate their software delivery process. Okay, I see the first responses come in. Keep filling in those questions. It's true or false. There's no right answer. There's no wrong answer. And while you're filling that in, what I want to talk about is testing in modern times. So what I'm going to do is I'm first going to kick off with telling you about testing and quality. I think that's a good thing that you know how I think about those topics. Then I'm going to talk a little bit about software development, then about learning, and then we're going to come to how you can speed up and do better testing using testability and having some insight in learning in teams. So I have 12 responses now. Awesome. Keep them coming. If I have 20, I will start going through the results. Okay, let's see if we can go through the results for now. Let me share the Google Doc. So these are the responses. Quality means the best possible product we can build. 33% thinks that's true. Well, I'm going to talk about that later. I do not fully agree. The goal of testing is finding bugs. Many people think that's false. That's awesome, because I think testing is way more than only finding bugs. Testers are responsible for the quality of the product. 48% think that's true. I don't think that's true. I think that it's a team responsibility. So, but okay. Testing is a phase. Well, the last talk talked about testing in DevOps, and there are several places where you can test. I think testing is a continuous thing in teams, so it's absolutely not a phase. It's a thing you do from start to finish. Testing is writing test cases and execute them. Okay, I'm happy with those answers. I absolutely disagree with that. I think testing is about learning and about getting to know the product and about determining the status. So it's way more than only test cases. If the product confirms the requirements, we can ship. 72% think that's false. That's awesome, because I think there's much more we need to do than only confirm the requirements. We talk about that as well. We do explicit risk analysis in my team. Only 57% does that. So the other 43%, I would encourage to look into that, because I think risk analysis is very, very important. I'll talk about that a little bit. We can automate all testing. Well, nobody thinks that's true. That's amazing. That's the first time I see 100% on this question. That's so true. So not true. I mean that we can automate everything. So that's, I don't have to explain that to you. That's cool. Test automation saves time and money. Many people think that. I don't think it saves time and money. I think it will speed up delivery, which of course saves time in a certain way, but I really think test automation is expensive. I'm not saying you shouldn't do it. I think there's absolutely a very important place in software development, but test automation will cost you money instead of save you money. And we don't need dedicated testers. That's, many people think that's false. Well, it depends on the context, but in most cases, I would recommend my clients, please hire dedicated testers, because those people are important. Cool. Let's go back to the slides, and then let's dive into this talk. So let's talk about testing and quality. for me, testing is something that informs decisions about risk and quality. So there are teams, but also managers, product owners that need to take decisions. Are we going to release this product? Do we want to make it better or something like that? So testing delivers the information to take those decisions. And for me, quality is just value. And just value as in, it's a simple definition. But there are many, many aspects of quality. And it's value to people who matter. For instance, if you think about the quality of coffee in your office where you work, the people who never drink coffee do not really matter if you want to talk about the quality of the coffee, because, hey, they don't use it. So it's value to people who matter. As said before, quality is not performance requirements, and quality is not the best product possible. Just think about your car or I don't know, your TV. There are much better cars than the one I drive, or much better TVs than the one I bought yesterday. But this product, the television that I bought, is good enough for me. I don't need an 8K television. I don't need a wide screen that's like 2 or 3 meters wide. I don't need the best quality in my house because I hardly watch TV. I play a little bit with my PlayStation, so I want good quality visuals, like the video, but it's not important that I have the best possible TV. It's the same with my car. So for me, quality products solve the problem, like getting me from A to B for my car and showing me some visuals when I play video or when I play with my PlayStation. And the products are good enough. James Bach once said, testing is not about assuring conformance to requirements, but it's rather about understanding the requirements. And I think that's also what testers really should take in mind. It's learning about the product. It's getting the status of the product and then see if it's good enough for the people who matter. And it's, of course, requirements help us with that, give us acceptance criteria, but there's way more to that. So, value for who? Well, value is in the eye of the beholder. I am a Lego fan, and I am happy to pay a lot of money for awesome Lego sets. But I know people who say, Lego is way too expensive, and I'm not going to buy expensive Lego sets. And I fully understand that because they probably don't value Lego as much as I do. So I am willing to pay a higher price. So value is in perception, but who's doing the perceiving? And value for who? There are many, many stakeholders in determining quality of a product, like the business, the customers, suppliers. There are many, many stakeholders in it. And these quality aspects often conflict. And that's interesting to see because we as testers collect information and then we deliver it to the people who take the decisions, and we maybe assist them in taking a decision, but I never take the decision if the product is good enough. I don't think that's something a tester should do. I think testers should collect the information. So value to customers. Because a customer doesn't buy requirements or doesn't buy a product, but customers want to achieve a goal or solve a problem with the software we build. And that's something that we sometimes forget. At my current client, we're delivering a release next weekend. And first, we started testing, looking at features and looking at user stories, but not really looking at the goal of this system. And when we showed first release to the customer, they weren't really happy. It was working, and we had some decent software, but some of the things didn't solve their problem in a way they wanted it to. And we had a good discussion about it. So always think and talk and from a customer perspective. Have a lot of feedback loops. Talk to your customer often. Then looking at software development. For me, it's research and development, but more research than development. And of course, we have to create code, and that's development. But that's the easy part. And I'm not saying that coding is easy, because I think it can be pretty complex, but finding out what to code is way, way more difficult. It's way complex. And why is that? Well, it's because software is complex. It consists of many modules, many procedures and functions and classes, and millions of lines of code. And in most software, there's not one person in the organization who completely knows how everything's working. So we have to collaborate, and people are complex because we have different languages, we think in different ways, we have different characters. And you probably noticed that with some people you have a good relationship, and with others, communication is a little bit more difficult. But software we create with people, for people. So we have to understand other people, and we have to work together with other people. And then, well, that's complex because people are irrational and we have emotions. So if you catch me today, I'm happy because it's only almost weekend, and I'm going to Germany next week, and well, we're releasing this weekend, so I'm pretty happy. But maybe if we start finding serious issues next week in production, that I'm not too happy, and then it makes it harder to work with me. Maybe that's what happens when people work together. And then it's not only the product that's complex or the people you work with is complex. We also have a VUCA world out there. It's volatile, it's uncertain, it's complex, and it's ambiguous. And we have these four things, like having a product vision helps you to be less volatile, and understanding the context will make things less uncertain. But we have to deal with these things, and these things come with risks. And looking at the poll questions, there are at least 40% of the people in the audience who do not do risk analysis. But how do you deal with these things? How do you discuss this in your team? Where are the risks? And one of the most important questions that I think a tester has to answer is, how should I test this? And how do you determine what to test? So you probably do an implicit risk analysis, but how do you get feedback on your thoughts on risks? I would recommend to start writing those risks down. It can be an easy list. And then talk to other people, talk to your customer. Hey, do you also recognize these risks? And while brainstorming with other people, that list gets bigger and bigger, and you get a better insight on what are the risky parts of your product. And the last thing I want to tell about software is that software development has to deal with unknown unknowns, things you do not know that you do not know. That's where bugs appear. Like, hey, this rocket, the Ariane 5, which exploded because there was an integer value that the value that has to be stored in that integer became too big, and they didn't know that could happen in that specific place, and then a serious bug was found because the rocket exploded. But also, when I bought my new television, well, it was 10 years ago I bought the old one, so I had to really dive into it and find out what televisions are all about. So as soon as you want to determine if a product is good enough for you, then, well, you have to do some research, and then you find out, hey, I didn't know that I didn't know that. I found all kinds of things, like smart TVs and apps that you could use, and calibration of the screen. So I didn't really know what I wanted until I saw it. And it's the same thing with our customers and product owners. They don't know, or they really can't imagine what they really want until we show it. That's why we need to do agile development and show them small increments and get feedback on that. But also development teams often cannot imagine what the customer will actually do with the product. So we have to talk to our customers. We have to work with them. So we need to do research. We need to build new insights and do evolutionary design to deal with this complexity, confusion, the changes we see, the new insights and the half answers. And that has all to do with learning and dealing with risks. So sometimes people ask, what's the business case of testing? And I would rather state that as what's the business case of learning, because I think testing is learning. It's learning about what the product actually is, what it should be, if it's working, if it can work, all those things. And the question is, do you value learning? Do you want to know what's actually going on? And if so, how much are you willing to pay? And if you value it enough, you won't discuss the price. But are the costs justified? And that's the juggling we as testers always have to do. Do we do a little bit more testing? Yes or no? And in my the project that I work with, and I did quite a lot, in my experience, I see that testers often test too much or want to test too much because we're risk averse. So are those costs justified? But sometimes we want just to make speed and then we test too little. So to find the right balance on testing enough, we really have to talk to the team and to our customer and maybe product owner and some other stakeholders to find what are the risks and how can we mitigate them. So how do you learn faster? How do you test faster? It's all about testability and learnability. Well, testability is how easy is it to learn or to test a particular product in a given context. And there are a couple of sources that I really want to point out here so that you can learn about it. I'm not going to go into much detail because they're all available. The 10 P's of testability, taken from the book, The Team Guide of Software Testability by Ash Winter and Rob Meany. Looking at these 10 P's, people, philosophy, product, process, project, etc., you probably see that, well, but all these aspects, this almost my complete product, it's the context of the people I work with, it's everything. And well, I think testability is in everything. And if you want to speed up your testing, if you want to do better testing, dive into this testability. Another resource is from James Bach, Heuristics of Software Testability. He sometimes uses kind of difficult names like epistemic testability. Don't let those terms scare you. It's an awesome checklist to talk about testability with your team. And Maria Cadamo also made her own model and wrote about it. And these three resources really give you a good insight on how you can deal with testability and make it better. Well, then a little bit about automation. And you already told me in the poll that you think we cannot automate everything. That's awesome. But still, let me go through this. Automated checks give you a binary answer to a question where you already know the answer because you can predict the outcome. So automated checks do not learn, but they really help us speed up development, and that's awesome. And they give us early warnings. It's like the lights on your dashboard in your car. As soon as you run out of oil, the light will turn on. And it will tell you there is something wrong with your oil. Something has changed. That light cannot tell you what the exact problem is, but it will give you an early warning like, hey, something has changed in this car and you really need to pay attention to that. And that's awesome. That's what we want. So these regression checks we do, what we automate, that's awesome. But we need people, sapient people, people who do exploration to provide new insights in the product. And only people can do this. And automation can help us with a lot more, like data entry and setting up environments and creating cases we can use to do further testing. So automation is really good, and it helps and assists the testing, but we also need a lot of new insights in the product. And exploration can do that for us. So we cannot automate everything. And unfortunately, I see a lot of people still claim that we should. And I think we don't. Can everybody test? Well, sure. But the question is, how good do you want me to be? Next week, the World Championship Soccer starts. And I'm a pretty good soccer player, but I'm old and I'm not far as good as the people who are on the field there. But hey, I could participate, but I'm not good enough. So do you want to do world-class testing in your project? Then you need world-class people who know how to do testing. And most people do not like testing. In my current assignment, I have 2 teams, and out of 8, 9 developers, only 2 or 3 really interested in testing. And they often help us, and they do a lot of stuff to assist us. And the others like, nah, I like development, I like coding. As soon as I'm done, I do some unit testing, and then I'll push it to the testers. And they will never be good at it. So they won't find the bugs. And this project where we're currently on started without testers, and we're still suffering from bad quality in the product because it wasn't properly tested. I think the obvious bugs they found, but the more deeper bugs and the more problematic bugs, they didn't. And we're still dealing with that. So we need smart people with critical distance to do skill testing. And with critical distance, I mean people who can step away and not think like, yeah, but it's my child, I made this code and I really want it to work. No, the people who have a problem mindset. I'll dive into that a little bit later. So we have to answer this one important question. Are there problems that threaten the value of the product or the on-time successful delivery of the product? So are we still talking about testing? Well, I don't know. For me, everything I talked about is testing. But for some people, testing is less. It's creating test cases, it's executing them, and it's doing validation and verification. And those are important parts. But for me, testing is all about learning about the product, and validation and verification is part of that. But there's so much more. So critical distance, we have 2 sorts of mindsets, and we both need them. On the left, it's the opportunity mindset. It's the people who solve problems. It's the developers, it's the product managers, it's the Scrum Master, it's the product owner, it's the business analyst. They find solutions for problems we have. They solve problems of the customer, and they ask a lot of questions like, how can we do this? And when can we do this? And then we have the testers, and they think in problems. So they search for problems, and they ask, yeah, but wait a second, what if this happens, or what if that happens? And this really helps from 2 perspectives. The first perspective is actually really learning about what the customer wants. We have a solution, and what can go wrong? And by combining these two trains of thought, we get deeper solutions. We get a deeper insight in what the product actually is. And the second perspective is that in the end, as soon as something is ready, and it can be an idea, it can be a piece of code, it can be a part of the software, but it can also be a complete product, then testers search for those problems. And well, as I often say, testers make other people look good because we prevent problems from happening in production. So it's all about learning in teams. It's all about loops. It's the old-fashioned, but still very important plan, do, check, act. So make sure that you plan something to do it, check it, and then change it. It's loops. It's creating something, looking at it, and then see, hey, evaluate it, and see if it needs adoption. Do it in team collaboration, and skills are key here. So optimize your software development lifecycle and processes, but also do it with a whole team. Find risks, mitigate those risks, create insight and what can go wrong. Test your requirements and assumptions continuously. But also, testers help teams to go faster. You can create development and release pipelines, automated checks, do code quality like static code analysis, and use useful metrics. So if you want to change something, if you want to improve something, find the metric. Do not start collecting all kinds of metrics, because then you will overwhelm your team with information. I don't care how many test cases you execute. I'm interested in coverage. So what of the product you actually covered? And you cannot put that in a metric. You have to tell a story about that. Also, like I said, do not test too much, but also do not test too little. So good is good enough. And to be able to determine that, because that's a very difficult question to answer, talk to people about what you did and what's the goal and what have you found and which information do they need to take decisions. Think about your test and automation strategy, or even better, I started creating integrated quality strategies for the whole team. So how do we work? Where do we make sure that what we write down or what we talk about is actually the thing we want to talk about? So all the feedback loops are in there, pipelines, resharpers, stuff like that. Use tooling and automation, but also in your exploration, because exploration makes you learn, and you can use tools to find the right answers for you and to see how the product actually is reacting to what you do. Again, most bugs are hidden, and you can only find them by exploring. The biggest risk in software development is that we overlook a risk. And the last thing is, well, find appropriate risks by not testing. So modern monitoring, maybe testing production, etc. We don't have to test everything. Some things, like in one example I had, is that a team had some good monitoring on their environments, and they were monitoring the speed of transactions. So that's also a sort of performance test. So we could see that if those values went up, then hey, there might be something wrong, and we did a performance test. If the numbers didn't go up, we didn't do any performance testing. This is Jerry Weinberg, and Jerry Weinberg has a famous quote: "No matter how it looks at first, it's always a people problem," and it is. So in an organization, we have the system and we have the behavior, and the system is the teams, the rules we have, the way of working, how we are organized, and that's all part of the system. And that evokes behavior of people working in that system. But behavior determines the success of the system. And research shows that the performance of the organization is determined for only 1/3 by the system and 2/3 by behavior. And that's an interesting thing to know, because this means that if we want to optimize our organization and our performance of our organization, an organization can be a team, it can be a department, but it can also be the whole organization. We should focus on how are people behaving, and changing the system. Well, it has some influence, but 2/3 is influenced by behavior, and that's really hard to change. So we need organizations that learn. We need teams that do deliberate practice. So here are some definitions I found on the internet, but what I want you to take away from a learning organization is that it encourages and facilitates learning in order to continuously transform itself. And why do they do that? Because they want to excel and they want to survive in a changing business environment. So to survive in the modern world, we need learning organizations. So I summed up a couple of characteristics for a learning organization, and one of the most important ones is the top one. Management and senior management need to encourage learning. And this is where it goes wrong often. If you have project managers who just keep pushing on, no, we need to deliver features, you don't have time to learn, then it all goes wrong. But we have a deadline. Oh, our customer really paid for this and we really need to start delivering it. Again, creating software is all about research and development. And research is learning. So you need safety, of course, and you need a growth mindset, and we need to orient on people, and we need to make it part of the way of working. So a couple of concrete examples of learning in organizations is do a development day. Like one organization I work with, the first day of a sprint, everybody could do whatever he or she liked to do. So it could be learning, could be working together on technical debt, could be finishing the last sprint, but it could also just stay at home and read a book, or do an online course, or work with other people on difficult problems. And of course, it's about communication and teamwork and leadership and empowerment. That's all true. But one of the most important things is, do you managers encourage you to learn? In your yearly performance review, or in your weekly or monthly talk with your manager, do you talk about learning? So how to build it is, well, it's really hard to do, but the steps are quite simple. It's about plan, do, check, act. It's about creating feedback loops, but also use facts, use data. So measure what you're trying to improve. So, okay, let's say we do those development days. And how do you measure that the people are actually learning something? Well, maybe you could measure it from the happiness of the people, or how they grow in their role. And how do you measure that? Well, maybe look at, like, is the product actually better, or do we do more a deeper refinement, stuff like that. Use data to actually see if you're improving. Then, of course, do a lot of experimentation, because organizations are complex. We are complex. We cannot predict, like, okay, let's do a dev day and then see if it actually works. Well, it probably will work, but how do you organize such a day? Well, experiment. Try something, see if it works. If it doesn't work, change it or do something different. Look at your past experience, learn from others. So get together, do retrospectives, talk about learning, and spend a significant time per week or per month on actually transferring knowledge. So do lunch sessions or knowledge transfer sessions, or invite external speakers to talk about stuff that is important that people learn, or let product owners talk to your team and give some insight, or user expert to give some insight in how they actually use the product, stuff like that. Or just go on a trip to your customer and ask, hey, can I just spend the day with you and see how you use our product? Stuff like that. So continuous learning is a given, because we are creating complex product built by and with people for other people. So continuous learning is key. But what do you need to learn? Well, there are so many aspects, like what the customer actually needs, what the product actually is. Because your product is not a bunch of requirements. It's a solution to a problem at your customer. It's learning how to work together. It's learning how to make the technology work. It's learning how to keep up with the constant change, or to get better at whatever you want to get better at. Create some goals, talk to people about it, organize it, and measure if it's actually working. So how to learn effectively as an individual? First, it's showing up. And what with showing up, I mean, stand still for a while and pay attention, focus. Because if you want to learn, you have to stand still. You have to take a step back because your brain needs the full attention. And if you're working in a project where everybody keeps bothering you and asking you questions, then I think it's hard to learn. So lock yourself up in a meeting room and spend an hour or two actually learning. It takes time, curiosity, some play. Don't be afraid to fail, because you will fail and you do it often. And that's okay, as long as you learn from it. Then I don't call it failure. It's just, hey, I just found another way how it doesn't work. Now let's see how we can make it work. Stop being learned helpless. With that, I mean, it's, yeah, I can't help it because blah, blah, blah. It's always another part of the organization or another person or another team or something outside yourself. And sometimes that's the actual case, but many times, what did you do to make it better? What did you do to change it? So do a lot of reflection. And I wrote a blog post about it, and I will share the slides so you can find that blog post. It's about how does reflection actually work? So to improve our testing, to improve the performance of the organization in general, you have to change your behavior. You have to start learning. And behavior is actually doing. It's not knowing or understanding or being able to. No. It's actually making changes. So behavior comes from thoughts, and your thoughts come from what you believe, and what you believe comes from experiences. And sometimes I see people trying to convince other people. So you're trying to change somebody's beliefs. That's not really working. What I would like to advise to you is try people to do an experiment, change their experiences, then they will change their own beliefs. So it's all about people and loops. Fast learning in teams, it's taking quality seriously and looking at it with a whole team. Okay, let's take a question. Are there any questions? So I'm kicked out of this room, so I'll find another place while I answer your questions. No worries. I'll dive in the answers of the questions. So, do you think quality is all about customer satisfaction? Yes and no. There you go. Yes and no. I think part of it is quality, is customer satisfaction, but what do you mean with customer? Because I think a team is his own internal customer. So we really have to pay attention to technical things like software quality, technical depth. And if we only listen to a customer, they won't probably want you to pay any attention to changing technical depth, because, hey, that's not delivering real value to them, because it's not, they can't see it. So I think quality is yes, mostly it's about customer satisfaction, because they're probably paying for your product, but there's much more, like the technical satisfaction. Okay, then are there new concepts like involving developers for testing, pair testing? Is that threatening the existence of dedicated testers? Well, no. It's changing the role of a tester. Where 25 years ago, I was the only one testing in a team, and I did everything because they were like developing stuff and then they pushed it to me. But nowadays, I work really closely to developers. I'm not a real programmer. Although I have a programmer background, I do not really enjoy it. So I work with my team. I am the lead. I am the coach. I am the service guy who help teams do good testing or better testing. So I coach them. I ask them, hey, let's do some automated checks, and they do the difficult part of the coding, and I'll do the easy part. So we help each other. And it's helping the developers do better unit testing, do better integration testing. Because I think a lot of the testing we do via the GUI can easily be done in a service level, on IPA level, maybe even in a unit test. If you're checking boundaries, often it can be checked in a unit test. So work with your developers. So is it threatening the existence of dedicated testers? I don't know. I don't think so. But what is happening in the world out there is that the functional testers, the testers that only do old school functional testing, those are just, I think, a little bit in danger, because we don't want functional testers. It's like the speaker before me said, we need to up our game. We need to be a little bit more technical. I'm not saying that every tester should code, but every tester should, well, I think, be able to read code and to talk to developers about how to do good integration and unit testing. Does that answer the question? Said developers don't like testing much. That means you don't have separate quality assurance engineers for testing. Well, yes and no. It seriously depends. Again, for me, I'm a context-driven tester, so everything depends on the context. Everything, I always look at the context. And in some contexts, it's really good to have separate testers. And in other contexts, it's okay to not have it. How important, how difficult, how complex is the testing that you're doing? And how willing are your developers to help you? And I have seen developers who do awesome testing, but it's really hard for a developer to switch from a problem mindset to an opportunity mindset and back. So even in a team of developers, if I would coach them, I would advise that in a sprint or in a release, somebody should wear the hat of responsible for testing. Not that he should do all the testing, but make sure that good testing gets done so that everybody is involved. So how do we focus on timely delivery of a product while being a learning organization? That's a very good question. Well, learning should be part of your work. And I never ask for permission to do learning, because I just do it. I make it part of my work. And if you spend like half an hour reading a blog post or researching something per day, then nobody will really say like, hey, you're not doing your job. Because I always am capable of answering the question, hey, I am doing this because I want to get better at, I don't know, API testing or contract testing or performance testing, or hey, I'm researching this because I want to learn about these products I'm working on. And we're a telecom organization, so I really want to know how this protocol works. And it's also, if you have a hard time getting some time for learning, then start talking to experts in your organization. Because I've almost never found an organization that objects to that. So just talk to other people and start learning together. So timely delivery of the product depends on learning. The more you know, the easier you can do your work. The better you understand the customer, the less time you need to actually develop a valuable product. So learning is part of your work. And there's the contradiction and there's the paradox in there. Some people don't see that. They see software development as, hey, we write requirements, then as soon as they're signed off, then we'll build the product. That's not how it works. That's maybe how we build cars or houses, but it's not how we build software. How can we improve thinking from a customer's perspective? Yeah, that's a good question also. Just talk to the customer, seriously be interested. I did a project once where we were creating a customer relationship management system for a newspaper and some magazines. And people would call the call center and they would change prescriptions and stuff like that. And it looked really easy to me. So I said to the people I had to work with, I was acceptance test manager. I said, okay, let's start thinking about testing. And then they said, no, you don't know anything about our product. So they made me do the introduction and introduction training of 2 days, which the call center people were doing. And after those 2 days, they said, okay, now sit next to a call center agent and listen to conversations they do. And I did. And in day 4, they said, hey, next call is for you. So I found myself, hi, this is Huib Schoots, Telegraaf Media Group, how can I help you? And I was actually using their old system. That made me learn about the product so well. And if you can't reach your customers, go talk to the service people, the service desk or the service representatives. They talk to the customers every day and they take their complaints and they take their questions and they take their problems. So really focus on how is the customer actually using. That's one thing. Another thing, it's also a bit more synthetic, but using personas could also help. So what's the best way to learn about a new domain? Banking? Ooh, that's a very hard question to answer. It really depends on how you like learning. I like reading books. I like talking to people. I love sitting next to people and say, hey, can you just explain to me what you do? So pairing with other people. But I also know people who are more into videos or more into well, let me do the work and then assist me on how to do it. But one of the best things to learn about a new domain is talk to people in that domain and ask how they learned what they know. So in a specific bank, I worked in a bank once, and we were dealing with transaction systems. So systems that would administrate and process transactions of billions of people at billions of dollars a day. And I took an official certification course that gave me some background information. I read 1 or 2 books about it, but I also Googled a lot on the internet how to on this company and the competitors of this bank and what are they actually doing, trying to learn the lingo and the slang they're using, and then talk to people and listen to them. What do you think about quality in gaming? That's a good question. I've never tested a game. I would really love to, but I think it's nothing like playing a game. So it's really hard for me to answer this question. I play games like Assassin's Creed and what's the other game? Gran Turismo. I think they're really good. They're especially with my new television, they're awesome. Good sound, awesome visuals. But again, I also play World of Warcraft, less good quality graphics, but awesome gameplay. So it really depends on what you're looking for. I think testing a game is a very different thing that we're in. Testing like insurance or banking systems. Okay, last 2 questions. Sometimes you're 100% sure that the end user won't do something in production, but still it's a valid test case. Can we skip? Yeah, that's a good question. Well, yes and no. I really need a context for this to answer this question. I think you can never be 100% sure that the end user won't do it, because hey, sometimes they won't do it deliberately. but it still can happen and it can make your system crash. So I don't know, it's really hard. Talk to your customer, talk to your product owner and say, hey, I have this test case. How valid do you think it is? And sometimes people say, well, it's not valid, and we're the tester. So we are the expert in thinking from problems. So then you have to push back and say, well, I really think this should be tested, and listen to other people and then make a decision about that. And the last one, then giving estimations. Should we always keep a buffer for learning? Yes, absolutely. Absolutely. But it's really hard to put that together. First of all, I think estimating testing is really hard because it really depends on the quality they give you. It's the installability. It's, do we have the right data, the right environments, blah, blah, blah. How is the testability of the system? So that's really hard to do already. So what I always do in when I'm estimating things is I will just, especially in a new project, I'll take an hour a day just to say I'm unavailable. So I will just plan like 5 hours a day, 1 hour for meetings, 1 hour for unexpected things, 1 hour for learning, and then I have like 5 hours left per day. Sometimes I do it like that, but yes, you should take a buffer for learning. I would block it in your schedules if possible. Okay, I think we went through all the questions. So everything I do comes with lifetime technical support. So find me on LinkedIn, connect. If you have questions, feel free to ask them. I'm really, really happy to answer them. And I hope to see you again. Thank you for listening.
Thank you so much, Huib, for that insightful session and sharing your knowledge with the audience. So,
Welcome.
and with that, we have reached the end of the Quality Week series. We would like to once again thank Huib Schoots and Prasadie Senadheera and all the other amazing individuals who have participated in the Colombo Quality Camp Community's Quality Week 2022 by sharing their knowledge and expertise. So before we wrap things up, let me welcome Dula and Gitanage to give away the vote of thanks on behalf of the Colombo Quality Camp. Over to you, Dula.
Hi, good evening to all of you. On behalf of the Colombo Quality Camp, I would like to take this opportunity to express our gratitude and say a huge thank you to the whole team who supported us to make this event a mega success. And first and foremost, I would like to thank our guest speakers, Rasika Mahindasiri, Niroshan Madam Pitige, Sachit Pereira, Gimhani Pereira, Tanushka Ranganath, Connor Fitzgerald, Chandimata Pattu, Sugandhika Amaradasa, Huib Schoots, Prasadie Senadheera. And without your valuable contribution, this event would not be possible at all. So I would like to thank you all. And also I would like to thank all participants from all the entities, including universities and organizations. And guys, we will be sharing the recorded sessions for all the participants by next week. And please fill out the survey that we are going to send to you to get the feedback for the entire Quality Week. And please do provide us your valuable feedback and let us know what sort of sessions you would like to see from us in future. And a special thank goes to our strategic partner 99Next for facilitating this event and our ticketing partner mytickets.lk. Last but surely not least, thanking our amazing organizing team behind this event. Without your support, we would not be able to make this event a reality. Stay tuned with us for all the future events that we are planning to host, and we wish to see you all of you in our next year's Quality Week as well. Thanks, and we are signing off from Quality Week 2022. Over to you, Dini.
Thank you so much, Dula. So with that said, thank you all for your presence and thank you for joining us and being an engaging audience. So let's meet again in the future with much more exciting events like this. Have a wonderful evening, everyone.